Hi everyone, in this particular video we are going to discuss about Leetcode weekly contest 402. We'll start with the very first two problems. And first problem was easy, like the constraint. We'll go through the problem itself. So I hope this is visible. This is the first problem. The problem is like this. You are given an integer array hours representing time in hours. Return an integer denoting the number of pairs I comma j such that I is less than j and sum of those hours forms a complete day. Or in simple words, a complete day is defined as time duration that is exact multiple of 24. So basically we need to find how many pairs are there. So we are given an array. Name of the array is hours. We need to find all such pairs I and j such that I is less than j and their sum is divisible by 24. Or I can say mod 24 is 0. Mod is used for finding the remainder. Whenever remainder is 0, it means the sum you are getting is a multiple of the number from which you are doing the modulo. Okay. So we need to count such pairs. In first problem, the constraints are, as you can see, the length of the array can be up to 100. So you can actually find all the pairs. Those who don't know, so how the pairs are going to be formed is, I'll give you one example. Suppose we have an array like this. So first pair is going to be formed between 1, 2. Next pair is between 1, 3. Next pair is between 1, 4. So for 1, how many such pairs are going to be formed? We'll find that. So in this case, you can see number of such pairs is 3. Now for 2, pairs that you can form is 2, 3 and 2, 4. Why I'm not taking 2, 1? Because that is not a valid pair because you need to make sure I is always less than j. Okay. So you are going to form 2 pairs in this case, and for 3 there is only one pair, that is between 3 and 4. Number of pairs that are possible is 6. Or I can say for very first index, if you'll observe, we have n minus 1 options because one space is utilized by that number itself. Now for next we have n minus 2, next we have n minus 3. Eventually for the very last number there is 0 options. Okay. So number of pairs that are going to be formed, if I remove this 0 which is not required, is going to be 1 plus 2 plus and so on, 3 plus and so on till n minus 1. So this comes out to be, if you remember, sum of first n natural numbers is n into n plus 1 by 2. But here what is the nth value? It is n minus 1. So if you replace this with n minus 1 here n, then you will get n minus 1 into n minus 1 plus 1 by 2, or which is n minus 1 into n by 2. So these many number of pairs are going to be formed. The logic or what I am trying to say here is you can actually try to form all the pairs because n is up to 100. So in worst case, you are going to form n square, roughly n square pairs, which will still be 10 to the power 4. So those are possible. So for problem 1, you can directly find or try to form all the pairs and check if they are multiple of 24 or not. I'll show you. So here let us take an variable answer, which is going to count how many number of pairs are there, or I can write total pairs. So always try to take readable names. So if somebody, some third person is trying to read your code, he or she should be able to read it and understand what's actually going on. So now what we have to do is for every index, we'll try to form the pair. Now I'm coding in C++. You can use any language of your type. Okay, we'll add the code of Python and Java in description. Okay. Eventually, a simple tip is you can use ChatGPT or other AI tools for converting your code from one language to another. Okay. But yeah, make sure sometimes they do their own changes. So make sure it is working properly. Okay. Now, what we have to do is, so for every index, so if you are present at index I, then the very first pair you can form with I plus 1th index, and then with I plus 2th, then with I plus 3, because those indexes are greater. And in pair I comma j, so I should always be less than j. So you need to take that in mind. So j is going to be starting from I plus 1, j is less than n, and plus plus j. Here you'll find what is the sum of elements. So you'll find the sum. If sum is divisible by 24, then you will increment the total pairs count. Okay, that's it. So here what you are doing is you are finding all the pairs and checking the condition is true or not. Okay, let's try to run this. Yeah, so it is passing sample test cases. Let us try to submit it also. Yeah, and it passed. If I try to submit the same code for part 2, let's see what happens. Mm, I was doing my homework before explaining it to you guys. If I try to do the same, but yeah, I need to make sure the return type is long long. So here it is long long. Let us try to submit this code. It's the exact same problem, but the constraints are changed. So we are getting TLE. Okay. As well as you will get wrong answer also. Let me explain you why. Because if you look at the constraint, I think as I explained, almost n square pairs are possible. You can form almost n square pairs. If you put the value of n in this case for problem 2, so the array size in this case can be up to 5 into 10 to the power 4, which is like 5 lakh elements can be present in your array. So in part 2, you need to take care. So always try to look at the constraints carefully. So here n can be up to 10 to the power 5. So n can be up to 10 to the power 5. 5 into 10 to the power 5. If you put this value in this expression, which is n minus 1 into n by 2, which is nothing but n square minus n by 2. And we already know in case of time complexities and all, like the n, if the n increases, n square is going to be huge as compared to this smaller n. So we neglect the value, or what I can say, it is not of that much importance. Okay. So n square, we are going to take approximately n square pairs are going to be there. So in this case, if you do the square of this comes out to be 25 into 10 to the power 10, or 2.5 into 10 to the power 11. That many number of pairs are going to be formed. And remember one thing, I don't know if you know this or not. So your loops, which we were using for finding all the pairs, they need to run these many times. But remember, in 1 second, for any program to avoid TLE, it should not perform more than 10 to the power 8 operations. Okay. So if a loop is running n times, it is performing n operations. So for a program to be accepted, or you should not get any TLE within 1 second time limit, it should not perform more than 10 to the power 8 operation. But here, what is the total number of pairs that is possible? It is 2.5 into 10 to the power 11. So obviously, if you'll keep on trying, To form all the pairs, you will get TLE because number of operations are much higher than 10 to the power 8. Now, remember this is very standard problem, and I'll explain the logic for this, and you'll be able to understand. Like this type of problems repeats. Okay, this is a very standard problem, and in every one or three contest, one out of three contests, you'll be able to find this type of problems. Okay, so what is the problem? I'll take one of the examples to uh, make you understand. So suppose we have okay, yeah, we can take some, yeah, 72, 48, 24, 3, or we can change on our own 3, 18, then 3, 24. Okay, so here the pairs that can be formed, you can obviously see one pair can be formed between 18 and 6. One pair can be formed between 72 and 24. Now, let me take one more example. So, number of pairs in this case is 2. I'll take one more example, 48, 3. Now, let us have 18 here, then we have 30 here, then we have 24 here. Okay, so this is again one example we are taking. Again, you'll observe one thing, 18 and 30 are able to form the pair, and 48 and 24 will be able to form the pair. Okay, now you need to observe few things. The reason I took this two examples is I want you to observe few things. What you can observe is 72 is able to form pair with 24, and even 48 is able to form pair with 24. It means there is something common between 72 and 48. Similarly, 18 and 6 you are able to form a pair which is divisible by 24, and 18 and 30 you are able to form a pair which is divisible by 24. Now, what is common between 6 and 30? The answer for this is when you divide 6 with 24, the remainder that you get is equals to 6. Even when you divide 30 with 24, the remainder which you are going to get is equals to 6. Here also, when you divide 72 with 24, the modulo, when you do modulo with 24, the remainder you will get is 0. Even with the 48, the remainder that you are going to get is equals to 0. So reminders, here it gives you an idea. Instead of looking for exact values, why don't we look for reminders? When can we say a pair of numbers or present at elements present at indexes I and j, we can form the pair between them if the sum of reminders is divisible by or 24, or like you can take example in both case. Here 18 6, 18 is the remainder when you divide with 24, and 6 is the remainder when you divide with 24. So reminders for both 18 and 6 is as it is, 18 and 6. Now this number is divisible when you divide this number by 24. The remainder is 0, simply means these two numbers can form a pair which is going to be divisible by 24. Similarly, for 18 and 30, what's happening there? The remainder for 18 is 18 itself when you divide by 24. For 30 it is 6. Again, the sum of them is equals to 24, which is when divided by 24 gives you 0 as reminder. Okay. So you need to focus on reminders. That is the key here. Okay, so observation that you can make from here is focusing on reminder is much better option. Okay. So next task is what you can do is you can replace every number with reminder. Replace every number with its reminder with 24. Like it was 72, 3, 18, 6, 24. So you'll replace them with their reminders, corresponding reminders. Okay. Now your array will look like this. Now I'm telling you the trick. which works whenever you have to find the pairs. You have to find the ordered pairs I should be less than j and all. Okay. So how it works is you'll go from left to right in your array. You'll go from left to right in your array. The logic is, suppose when you're present at any index I, it means you have details about all the numbers from index 0 to I minus 1. Or I should say like this, you need to store some details. Need to store some details about elements which are present from index 0 to I minus 1. It is simple because you already have processed all the elements from 0 to I minus 1, then only you are present at index I. Okay. Now, what you actually do is, okay, so what is our goal? Here, the remainder of value is 6. So to form a pair, you need a value whose remainder is 18, which is present in this particular range. So you have to maintain a hash map or dictionary or even an array which is going to store details about this. Like here you want to check, is there any number present or how many numbers are present whose remainder is 18. So suppose if we have multiple numbers, like two numbers are present from 0 to I minus 1 whose remainder is 18, it means you can form two pairs. Okay, it's like that. And how we are going to get this, what is going to be the value you should be looking for? It is very simple. So reminder here is 6. Now reminder you should be looking for is 24 minus 6, which comes out to be 18. Okay, so you need to look for numbers whose remainder is going to be 18. Now how you are going to maintain is, for every reminder you will treat it as a key and its value is going to be, so we are talking about map here, map, dictionary or hash map you can use. So what you are going to do is you are going to map reminder with the count, where reminder is going to be the key and the count is going to be the value. What is the count? How many times that reminder is occurring. When you are present at index I, you already have processed all the values from 0 to I minus 1. Okay, but there is one edge case which you need to take care of. When the remainder is 0, 24 minus 0 will give you 24 only. Okay, so you cannot have any number whose remainder is going to be equals to 24. Whenever you divide any number, suppose you are dividing any number with 24, the remainder is always going to be between 0 to 23. So here to get rid of this, you need to do the modulo again with 24, this value. So 24 modulo 24 is going to be 0. Now it is correct. If in past there is a number whose remainder is 0 when divisible by 24, you can form a pair with current number whose remainder is also 0. So example we took like 72 and 24. 72 remainder was 0, 24 remainder was 0. Okay, so if numbers are multiple of 24, they can be used for forming pairs, which is again going to give you a sum which is multiple of 24. Okay, now we are going to apply whatever we discussed till now in our code. Okay, so I hope you understood why it was giving TLE, because number of operations that we were doing is lot. Now first we need to change this to long long. Next what is going to be there is I want to change my number to replace with the modulo value. So hours of I is going to be replaced with the modulo value. Okay, you can do all this in a single step, but to make it more readable and beginner friendly, I'm using elaborating a bit more. Okay, so we are going to replace our array with the modulo value of 24. Modulo value when modulo value of 24 make more sense. Yeah. Now what we are going to use here is a map. You can use dictionary and hash map according to your language. The use of this map is to get you the count. Like whenever you are present at any index, you will treat that index to be your jth index. Why j? Because we are focusing on j in this case. I should be less than j. So you, whenever you are present at any index, you are treating it as j. So for that, what reminder should be present for I, you'll find out, and using map, you'll find how many values are present from 0 to that index minus 1, which are giving you that reminder. Okay. So I'm going to map reminder is of int, but the count can be of int type, but here to deal with long, I'm taking long. Okay. Or let us keep everything in long, because in C++ we have this typecasting. So to not have any issues, we are using this. So the name of this is going to be count. Now we will simply go through our array. I should write it as n, all the valid indexes. Now I'll find what should be the reminder value of my reminder value of that is required for forming pair. So it is going to be equals to 24 minus what is the current value at this index. Okay, remember this is already replaced, we already updated hours of I with its reminder value, so I can directly do this. Now if you remember to tackle the case of 0, like when this value is 0, we have to do with modulo again with 24. Okay, now you have to check how many numbers or how many values are there. So if you are present at index I, so how many values in range 0 to I minus 1 are there which are having this reminder? Okay, rem. So we can simply use our find function in C++ for that. So this will check if this reminder have occurred in past or not. So this is the syntax for that. There is a find function for checking. In similarly in dictionary we have in Java also we have like the key is present or not, or the value is present or not. You can check. Now here if the element is present, our answer or the total number of pairs are going to be modified by how many times this reminder have occurred in past, because that many pairs you can form. So if 4 times that reminder have occurred in past, it means 4 pairs you can form. So this will give you how many times it has occurred in past. Now before moving to next element, what you have to do is you have to increment the count for current element reminder. Okay, so you are present at index I, so you need to increment the reminder for this element. Okay, so we are done with this. Now let us try to run our code. This code is going to be shared with you. So if the reminder is present, it means we can form values, we can form pairs. Pair is like, okay. So here I'll run the code and let's see if it is working fine or not, or we did some mistakes. So it is working fine. Let us try to submit it also. I'll discuss about the time complexity in this case. So it is accepted. Okay. Now the time complexity, coming to time complexity of this is we are running a loop n times, that is for sure. And we are doing query in map. If you remember in map in C++, it takes log of n times, where n is the number of elements in your map. So n time I'm doing query. So in worst case, the time complexity is n of log of n. Okay, which is feasible. 5 into 10 to the power 5 is there, and log value of this is going to be roughly around 18 or 19. So 18 into 5 is going to be 90 into 10 to the power 5. So which comes out to be 9 into 10 to the power 6. If you remember, 10 to the power 8 operations are allowed, and this is well within the range. So that's why our solution is passing. I hope you understood this. If there is any issue, you can comment down below, and also Codes are going to be shared for all the languages, Python, C++, and Java. Okay, feel free to reach out to me also. Discord link is going to be there where you can discuss your queries and even comment down. Okay, that's all. Thank you.